Hello dear students, I am Dr. Anita Kahar, lecturer from USPM Dental College, Nagpur, and your mentor for today's lecture, that is soldering and welding. Soldering and welding is very short and simple topic but very important for the exam point of view. In soldering and welding, we will be learning about the introduction about soldering and welding, definitions of soldering, brazing and welding, parent metal, dental solder, how the soldering is done, flux, anti-flux, heat sources used for this soldering and welding technique, soldering techniques, and the types of welding. So let us start with the introduction. In dentistry, as you all know, we construct the prosthetic appliances and the orthodontic appliances. But sometimes if the prosthetic and orthodontic appliances, if they are bigger, so you will have to prepare it into the parts and then you will have to join these components by soldering or welding procedure. And these metal joining operations, they are usually divided into three categories, that is welding, brazing and soldering. Now in dentistry, the word soldering and brazing, it is used interchangeably because in soldering, the soldering operations, they are done below 450 degrees Celsius, while in brazing, the all these metal joining is done at above 450 degrees Celsius. In soldering, it is done below 450, and in brazing, it is done above 450 degrees Celsius. But in dentistry, the joining of the metal parts is done at above 450 degrees Celsius. That means it should be ideally called brazing, but most of the dentists, they prefer to use the word soldering. So in some of the authors also they use the term brazing and soldering in one and the same thing. So if the question is asked either on the soldering or on the brazing, you will have to write the same thing. Only the temperature differences you will have to mention. So let us see the definitions. Welding. Now in welding, the two pieces of the similar metals, they are joined together without addition of the another metal. This is only the difference between the soldering or brazing and the welding. Because in soldering and brazing, there is an addition, means the joining of the parent metal is done with the help of the third metal, while in welding, it is not done. It happens because when you melt the pieces, when you melt the parent metal pieces, they at a high temperature, they join together by melting and flowing. So there is no, we are not adding another metal to join the two broken pieces of the metal. Now what is soldering? Now the metal parts are joined together by melting a filler metal. Okay, so this is a filler metal that we are adding between the two metal parts to be joined at a temperature below the solidus temperature of the metal being joined and below 450 degrees Celsius. Soldering is done below 450 degrees Celsius. And brazing means the metal parts are joined together by melting a filler metal. Again, there is a filler metal is there between them at a temperature below the solidus temperature of the metal being joined and above 450 degrees Celsius. The differences are only in the temperature below 450 in soldering and above 450 brazing. Now, if you are see here, you can see the solidus temperature and the liquidus temperature is mentioned in the definition. So, what is this? So the solidus temperature is the temperature at which the metals of an alloy system become completely solidified on cooling or start to melt on heating. Means they are the metal alloys, they completely solidify, they become totally solid when we cool the metal and they start to melt on heating. That means it is a solidus temperature, and the liquidus temperature is exactly opposite to it. So what is it? The temperature at which the metals of an alloy system, they begin to solidify on cooling or they become totally liquid on heating. Okay, here it is completely solidified on cooling, while it is they begin to solidify on cooling, and here they start to melt on heating, and here they become totally liquid on heating. So these two definitions are very, very important for the MCQ also, and yes, for the Viva point of also. Now what is parent metal? Parent metal is also known as substrate metal. Now the alloy or the metal to be joined by the soldering or brazing process is known as the parent metal. And the metal that is used for joining the two metals is known as the filler metal or a dental solder. That is a third metal that we will be using. What are the examples of this parent metal? The parent metal can be your gold copper, it can be gold silver, it can be silver palladium, it can be nickel chromium, or it can be cobalt chromium. Now the importance that you will have to give when we are doing soldering or brazing procedures, how your parent metal, you should know the details about the parent metal so that it will be easy for you when you selecting the dental solder or the filler metal. So you should know the composition of your material or of your metal. You should know, very important, the melting point of the parent metal. Your parent metal should be free of oxide layer, otherwise there will not be flow of the third metal, and your metal surface should be so clean that the filler metal, the third metal that you will be joining, you will be using for joining of these two broken pieces of the parent metal, so that it should weight the parent metal very nicely, otherwise there will not be soldering or brazing occurs. So this thing you should know about your parent metal. Now let us move towards the dental solder. That is the third metal, the metal that is used during the procedure of soldering or brazing is known as a dental solder or the filler metal. Now how your dental solder or your filler metal should be. These are the different properties that your filler metal or your dental solder should have when you will be doing a soldering procedure. Now the first thing is the fusion range. Fusion range means the melting of your filler metal. Now the fusion temperature of the solder, it should be at least 35 to 70 degrees Celsius below than the solidus temperature of the parts to be joined. If it is more, then it will cause casting to melt or distort. Means your melting of your dental solder or your filler metal, it should be low than that your parent metal. If it is more, then there will not be soldering occur properly. There will not be joining the two metals occur. So your dental solders melting temperature should be low than that of your parent metal. Then the flow. Flow means your dental filler, the solder metal, it should wait and flow, it should free flowing, so that there will occur and the soldering will occur very nicely. The molten solder must exhibit high flow characteristic when it is used to join the individual units of the cast assembly. In wettability, the solder should have ability to wet the substrate metal. If oxide layer is present on the substrate metal means your parent metal. So if the oxide layer is present on the substrate metal, spreading of the molten metal does not occur. And the very important, the color should match with the parent metal, so that there should not be, aesthetically it should be good. The tarnish and corrosion, yes, it should be resistance to tarnish and corrosion. The precious metal content of the dental solder should be 14 carat, so that there should be avoidance of the tarnishing and corrosion. The dental solder should be resistant to pitting during heating and application. Solder should be free of surface pits which lead to tarnish and corrosion, and ultimately low in strength. Now the dental solder should have the high tensile strength and ductility, as means it should be similar to the parent metal. If the ductility lays, so there will be a solder joint that will be happen after the soldering. It will be brittle and it is susceptible to fracture under the masticatory load. And the hardness, yes, it should have adequate strength. Now what are the different types of the solder? Now there are two types. Mainly it is divided into the two groups, that is soft solders and the hard solders. The soft solders have the low melting range, that is about 260 degrees Celsius as compared to the hard solders, and they are applied by means of your hot soldering iron. You must have been seen this in some of the electricians if you have seen their work. So they mostly use this type of the iron that is known as soldering iron. Now these type of the soft solders, they lack the corrosion resistance and they are not suitable for the dental use, because we know the temperature that you will be using in dentistry is much higher, and the examples of these dental solders are alloy, tin and lead, and these soft solders are most commonly known as the plumber's solders. Now next is the hard solders. The hard solders, they are commonly used in dentistry. They are having the high melting range and have a greater strength and hardness, and they are melted with the help of the gas blow torch, or occasionally electric furnaces are also being asked. The furnace picture I have kept in the next slides of the lecture. Now the examples of the gold solders are the hard solders are gold solder and the silver solder. Now here you can see the temperature range, the melting range, that is 750 to 900 degrees Celsius, and silver solders 600 to 750 degrees Celsius. Now the gold solders, they are used for soldering of the gold alloys, and the silver solders are used for stainless steel or base metal alloys soldering. These are the pictures of, this is the gold solder and this is the silver solder. What are the uses or application of soldering? As we have seen in the introduction part only, it is used in orthodontic and prosthodontic appliances. So larger FPDs, they are cast in parts and they are soldered. In RPDs, for soldering of the clasps, you can see the clasp here, we need a soldering process to join. Then orthodontic wires and bands, repair of the perforations in crown and bridges. So if the perforation has occurred in the crown or in the bridges, so it is economically to replace the new crown and bridge if the patient is not ready. So you can repair, or during the when we prepare it during the fabrication, if this occurs, so at that time also you can do the repairing and to develop the contact points in the crowns. You can see here, this is the picture. You can see this is the orthodontic, this is the molar band, and here the wire is soldered with this, and this is for the development of the contact points. This is just to give you an idea how the contact points are there in the bridge. Now next is a flux. Now flux is very important for the short answer question. Many a times short answer question is asked on a flux and anti-flux. We'll first see what is flux, after that we will see the anti-flux. Now what is flux? Now the flux has came from the Latin word that is flux, that means to flow. Now for a solder, that is a third metal, to wet and flow properly, the parent metal must be free of oxides, and this is accomplished with the help of the flux. So what does the flux does? Means the main role of flux is prevent oxidation, and it remove any pre-existing oxide coating on the metal surface to facilitate free flow and metability of the fluid solder over the metal surface. Now there are different types of the fluxes, mainly protective, reducing and solvent. Now if you see the example of any of these, you will not see one example of the flux is having a protective or reducing type. It is having the role of two or more. Means it can be protective, reducing, it can be reduced to solvent. So it does the function of the two or more. So the fluxes, now yes. Now how does the protective flux work? Now protective in the names, if you see the name only, protection means what? Means this type, if you are using protective type of the flux, means it is giving surface protection. Means this flux covers the metal surface and it will prevent the access to oxygen so that no oxide can form. So this is protective type of the flux. Next is a reducing. The reducing means if the oxide layer get formed, it will reduce them. Okay, means this reduces the any oxide present and it exposes the clean metal. Now solvent, as the name suggests, this type of the fluxes will dissolve any oxide present and it carries away. So in the name only the answer is hidden. Now there are availability of these fluxes either in the liquid form, either in the paste form, or either in the powder form. And the pre-flux solders are also available. So what are these pre-flux solder? The pre-flux solder are that the filler metal is present in the tip form and the flux is contained inside the tube. Means already there is a filler is there in the tube and already flux is present inside the tube. So you don't have to apply it separately before doing the soldering procedures. So what are the examples? And this is the most commonly asked MCQ questions. The boric acid and borax used for noble metals, and it is a protective and reducing type of the flux. It is performing the role of both protective and the reducing flux. Second is the fluoride type, that is potassium fluoride combined with the borax. This is used for the base metal alloys, that is protective and the solvent flux. It is having protective and solvent. So MCQ can be as the protective potassium fluoride is such type of the flux. So you will have to write accordingly. And also when we are doing soldering procedure, which type of the flux should be used? If you are soldering noble metals, gold metals, if you are soldering, then you will have to use boric acid or borax. If you are using base metal soldering, then you will have to use the potassium fluoride. So this is very, very important to have the knowledge about the fluxes. Now, whenever you are applying the flux before doing the soldering procedure, whatever the technique is used, it is very, very important so that you should use a minimum amount of the flux. Okay, so if the flux amount is increased, what will happen? The excess flux will remain trapped within the filler metal. Means whatever it will remain in the filler metal and it will cause the weakened joint. Second, if you are using excess flux, the residual flux that is remained over the porcelain can cause discoloration and bubbling. Third, flux when combined with the metal oxide, it can form a glass which is very, very difficult to remove. And if you are using a fluoride type of the fluxes, the toxic fluoride may release when hitting fluoride containing fluxes. So you will have to avoid the inhalation. That means you will have to take precautions whenever you are using the fluoride containing fluxes. So minimal amount of the flux should be used. Now what is anti-flux? Now as we have used flux, so you should have there is a very important role of anti-flux. It is difficult to control the flow of the solder metal when it is in the liquid state. As I already told you, the solder are available in different forms. It is available in a powder form, gel form, paste form, and the liquid form. So before doing the soldering procedure, what we do, we apply flux and then we apply the filler metal or a solder metal. So if it is in a liquid state, so it is very difficult to control the flow of the solder. What is our desire? Our desire is that solder should not flow into the specific area. Means wherever you require, it should flow in that area only. So if it is in a liquid state, it is very difficult to control the flow. And this flow can be prevented by using the anti-flux material. Now it is applied just before the flux or solder is applied. So it is a material used to confine or limit the flow of solder. So it is very, very important. So what are the examples? This is again MCQ questions. Graphite or soft lead pencil, rose, that is iron oxide, calcium carbonate, also known as whiting in an alcohol and water suspension. The most commonly asked short answer question, flux and anti-flux, and the MCQ questions are asked routinely on these topics. Now coming to the next, we have seen the flux, we have seen the anti-flux, we have seen the ideal requirements of the dental solder, how should be the parent, what should you know about the parent metal. Now the third thing, which is very important, the heat source, what you will be using for melting this metal dental solder to flow into the space between the two parent metal. So the heat source that is used, it can be a gas air or gas oxygen torch, or it can be your electric furnace. Now you should know, or you may be knowing, the different zones of the flame. So there are the oxidizing zone, then reducing zone, the partial combustion zone, and the whole mixing zone. Ideally, you should use reducing zone whenever you are doing soldering or brazing procedure. Also, when you are doing routine procedures in the prosthetic laboratory, in the preclinical works, you should always use blue flame. If you are using a red flame, there is a main, mostly if you have experienced that your work has become little darken, or there is a carbon content has occurred or it is appeared in your work, so that means your area of you're using the flame zone is incorrect. You should always use the reducing zone. Now, what are the objectives of heat source? How important is heat source? Heat source is very important part during the brazing or the soldering procedure. Now the flame, here you can see there that I have written high temperature and high heat content. Now what is this? Now the flame must provide enough heat not only to melt the filler metal but also to compensate the heat loss to the surrounding. So the flame should not only have a high temperature but should also have a high heat content. If the heat content is low, the soldering time required is very longer and there is a danger of oxidation. So your heat content of the flame should be high, and this heat content is measured in BTU, that is British Thermal Unit per cubic foot of gas. Now let us see what are the different gases that are used. Now you can see there are hydrogen, natural, acetylene, propane, and the butane gases are there, but which should be used? Now here you can see the hydrogen is having flame temperature and the heat content is very less as compared to the other gases. So because of this low heat content, it is not used for this procedure. The next is the natural gas. The natural gas is having the higher flame temperature and heat content as compared to the hydrogen, but it is not again it is not used because it is having the water vapor in it. That's why it is not used. The next is the acetylene. Acetylene is having a high flame temperature and high heat content as compared to both of the above, but it is again not used because um, if you see in the previous picture, you are seeing the different zones of the flame. So there is a temperature difference of more than 100 degrees Celsius in each different zones of the flame. So it is very difficult or it is very critical to keep the flame at one zone. So during this procedure, because of these differences in the temperature in the different zones by more than 100 degrees Celsius. The next is the propane and the butane gas. You can see they are having the flame temperature same and heat content is all of them same, and it is the heat content is highest than above all those three gases. So this is the most commonly used gases for doing the soldering procedures, and they are because they are uniform in quality and they are water free also both. And this is the electric furnace. Now here the advantage of electric furnace is that it is as you can see, this is a closed chamber and you will have to just keep your casting here and you will have to close the door. So there is a not only the heat is more, but also there is a the surrounding is provided is a heated surrounding. So there is a less chances of this, means there is less heat is lost to other parts of the breeze and to the atmosphere. Now, what are the soldering techniques? There are two types of soldering technique. One is a freehand soldering or the jig soldering. Now, here, as the name suggests, freehand soldering, you will have to assemble the parts with the help of your hands only, means manually, and the heat is applied. The parts are assembled and held in contact manually while the heat and solder are applied. Next is the investment soldering. Now, as the name suggests, the parts to be joined are mounted in the soldering type of the investment, and the harder investment hold it in a position while the heat and solder are applied. So here you will have to do the investing, and it is done with the help of this is a manual process. Now, what are the requirements for the successful soldering? So the first and very important is cleanliness. Cleanliness means the parent metal, it should be free of oxide. Otherwise, there will not be free flow of the solder metal. So first you will have to clean your parent metal with the soap and water. Then you should follow the thickening procedure and remove all the impurities present on the parent metal. Now the next part is the gap. How much should be the gap between the two parent metal? It is very, very important. Now the ideal requirement or the gap between the two parent metal is should be 0.13 to 0.3 mm. Yes, this is a suggested gap between the two parent metal. Now what will happen if the gap is more and if the gap is less? Now, if the gap is very less, if it is very narrow, it will there is a strength will be get hampered because of the development of the porosity. Because if the space is too narrow, there is incomplete flow of the filler metal, or there is a flux inclusion because the space is very narrow, or if the gap is too wide, what will happen again? It will hamper the strength only because the joint strength will be the strength of the solder metal, because the solder metal that will be using, it is little bit low in strength as compared to the parent metal. And second drawback is that there is a tendency for the parts to draw together as the solder solidifies. So in both the conditions, there is a reduction in the strength if the gap is less or more. Now next, selection of the solder. We have seen the ideal requirement, how your solder should be, the color, the fusion temperature, the flow, the strength, everything you should have to see. Then the flux type and the amount, you will have to see which type of the parent metal is, whether it is a noble, whether it is a base metals. Accordingly, you will have to use a gold solder or the silver solder. Now the flame, you will have to use the current zone, neutral or the reducing zone. Either you should use the propane or the butane. Then the temperature you should be, now the temperature that is used during the soldering or brazing procedure, it should be minimum that is required to complete the brazing operations. Okay, and the thing that you will have to remember that before placement of the solder, the parent metal is preheated so that as soon as the filler metal is touches, it flow properly, because the parent metal is um, having a already there is a heated parent metal. If because it may cause the otherwise it will not flow properly. Now the time. The flame should be kept in place until the filler metal has flowed completely into the connection, and means as soon as the flux and your solder has been the flux has done his role of removal of the oxide layer, and then the solder metal is flowed into the gap. So if you are giving a shortened time, so if you are applying for very less time, the flame is applied. So what will happen? There is an incomplete filling of the joint will occur with the parent metal, or the flux, only the flux inclusion occurs. And if the longer time is given, so there is a possibility of diffusion. In both the conditions, it will result in a weaker type of the joint. So the time, as soon as the solder metal has flown, you should remove your flame. Now this is just a summary what we are doing in a soldering step. So first you will do the cleaning and preparing the surface to be joined. After that, you will have to see how should the gap, that is 0.13 to 0.3 mm. Then you will have to assemble either your freehand technique or your investment technique. Then you will have to apply the flux and of course anti-flux. Then before applying the solder, you will have to preheat the parent metal. Then place the solder, apply the gas flame, and you will have to quench this assembly into the cool water so that it will get cool. So this is the steps of soldering. Now how the pitted solder occurs. Now pitted soldering joint occurs means there is a inclusion of the porosities. So it is due to the volatilization of the lower melting components, or it can be due to the improperly melted or excess flux entrapment. So to avoid the pitted solder joint, we will have to use less amount of flux. and remove the flame as soon as the flux and solder were melted and flowed into the joint area, that we have seen in the time consideration during the soldering steps. Now that was all about the soldering procedure. Now what is welding? Now in the first or second slide we have seen the definition of welding, where the differences between the soldering and welding is that we are not using a third metal to join. There is no role of dental solder or filler metal. Here during the welding procedure, the two parent metal, they only get melted and flow, and there is a joining occurs. So the process of the two similar metals by means of application of the heat without the addition of another metal in between. So there are three types of the welding: spot welding, pressure welding, and the laser welding. Now in spot welding, they are mainly used to join the orthodontic bands and the brackets and to join the orthodontic wire. This is a chair side procedure. If you have seen any orthodontist, so this soldering machine is kept aside his chair only. So whenever he wants to join the brackets or any orthodontic wires, the doctor does at the chair side only. Now here you can see the copper electrode is there, and this is all the procedure started with the help of all this. You can see the plug is there, and you will have to just keep this wire on the either a molar tube or the bracket, and it gets welded. Now this is a very simple procedure, and it occurs within a short period of time. Now here the welding occurs wherever you are keeping the bracket on the wire. So this occurs at the spot. So that's why this is known as the spot welding. The next is a pressure welding. Now pressure welding is also known as a cold welding, as does not require heat application. Cold welding, if I want to give the example, so the example is if you have seen the direct filling gold, in that the gold foils, they are gold foil restoration is done by with the help of the condensation, either hand or a mechanical condenser. So because of having the cohesive property of the direct the gold foils, they get condensed to each other, and this is known as cold welding process, because we are not applying heat. This is occurring just by applying the little manual or mechanical forces, and they adhere to each other. That is known as pressure welding. The examples are direct filling gold by hand or mechanical condensers. Next is the laser welding. The long form of this laser is a light amplification by stimulated emission of radiation. Now here a beam is focused at the joint to be welded. It is a micro welding procedure. It is used for intraoral orthodontic appliances. The advantages are it very rapidly it welds. This is an automated process. Bulk temperature rises small, and dissimilar metals can be welded. And the disadvantage is it is quite expensive. So this is all about the soldering, brazing, and welding. So very important topic for the short topic, but important for the short answer and the MCQ, and as of course for the Viva. These are the different references from where I have taken this topic. The expected questions are mainly short answer questions on flux and anti-flux, and one vague question can be asked, what is soldering and welding? So in that you will have to include all the what is solder, or yes, then on a short note can be asked on a dental solder, where you will have to write about the ideal requirements and the different types of the solders. So friends, I hope you understood the topic nicely. Thank you.